Earthquakes. When stress builds up in a rock, that rock breaks, creating a fault. And when that fault occurs, an earthquake begins. An earthquake releases an enormous amount of that stored energy that we talked about earlier. Thousands of earthquakes actually occur every day worldwide. An earthquake is the shaking and trembling that results from the movement of rock beneath the surface. While most earthquakes are too small to even notice, there are very large earthquakes that occur, and these can produce dramatic changes in not only Earth's surface, but also in building structures and roads. Since a fault is a break in the rock of the crust where rock surfaces slip past one another, rocks on both sides of the fault can move up or down or even sideways. There are three main types of faults: normal faults, reverse faults, and strike-slip faults. When there's tension in the Earth's crust and it pulls rock apart, this causes a normal fault. In a normal fault, the fault is at an angle so that one block of rock lies above the fault, while the other block lies below the fault. The block that lies above is referred to as the hanging wall, while the block of rock below is called the footwall. When movement occurs along a normal fault, that hanging wall slips downward. These normal faults occur where plates diverge or pull apart. When plates move past each other, shearing creates strike-slip faults. Strike-slip faults is when rocks on either side of the fault slip past each other sideways with very little up or down motion. The San Andreas Fault in California is an example of a strike-slip fault that is a transform boundary. In places where the rock of the crust is pushed together, compression causes reverse faults to form. Reverse faults have the same structure as normal faults, but the blocks move in opposite directions. In reverse faults, the hanging wall moves up relative to the footwall, and this type of movement produced per the Rocky Mountains in the western United States and Canada. When rocks move along a fault, they release energy that travels as vibrations on and in the earth called seismic waves. These waves act like a pebble thrown into a pond. The waves carry energy as they travel outward and they race in all directions. When we're talking about the earthquake, though, instead of a pebble, we know that the earthquake originates along the movement of the faults at a location inside Earth called the focus. Earthquakes can occur anywhere between Earth's surface and depths of greater than 600 kilometers. If you ever to watch a news report when a large earthquake occurs, the news will often identify the earthquake's epicenter. An epicenter is the location on Earth's surface directly above the earthquake's focus. The seismic waves will carry the energy from an earthquake away from the focus, through Earth's interior, and across the surface. There are three main categories of seismic waves: P waves, S waves, and surface waves. An earthquake sends out two types of waves from its focus, P waves and S waves. And when these waves reach Earth's surface at the epicenter, surface waves develop. Now, P waves, also called primary waves, are the first seismic waves to arrive. They are compression waves that compress and expand the ground kind of like an accordion. P waves are the fastest moving seismic waves and are the first waves that you feel following an earthquake. These are always these are the waves that damage buildings. Now, secondary waves, referred to as S waves, are slower than P waves, and they cause particles to move up and down at right angles relative to the direction the wave travels. They shake the ground back and forth, and when they reach the surface, they shake structures violently. Unlike P waves, which travel through both solids and liquids, S waves do not move through liquids. Now, when P waves and S waves reach the surface, some of them become surface waves. Surface waves move more slowly than P and S waves, but they can produce severe ground movements. Some surface waves can even make the ground roll like ocean waves, and others can shake buildings from side to side. Scientists that study earthquakes are called seismologists, and these are the scientists that people call when they want to know how big was the earthquake and where was it centered. There are at least 20 different measures for rating earthquakes, each with its strengths and shortcomings. But the three most commonly used methods of measuring earthquakes are the Mercalli scale, the Richter scale, and the moment magnitude scale. The Mercalli scale rates earthquakes according to the level of damage, whereas the Richter scale rates earthquake based on the size of the earthquake's seismic waves. And the moment magnitude scale is a rating system that estimates the total energy released by the earthquake. Geologists use seismic waves to locate an earthquake's epicenter. Seismic waves travel at different speeds, and as we talked about, P waves arrive at the seismograph first, with S waves following close behind. Using the P and S waves, scientists follow steps to locate the epicenter. First, scientists determine the number of seconds between the arrival of the first P wave and the first S wave on the seismograph. This time difference is called a lag time. The further away an earthquake is, the greater the time between the arrival of the P waves and the S waves. Next, scientists use a graph showing the P wave and the S wave lag time plotted against distance. And then finally, scientists draw at least 3 circles using data from different seismographs set up at stations around the world. The center of each circle is a particular seismograph's location. The radius of each circle is the distance from that seismograph to the epicenter, as you're going to see in the following figure here. Now, by looking at this step, here you can see the epicenter has been located at San Francisco, California. Okay, it's time to show what you know.